Okay, YouTube, in this module of videos, we're going to be focusing on complex numbers and plotting complex numbers in the complex number plane now that we've kind of considered polar coordinates. And so let's go ahead and start by kind of refreshing our memories here. When it comes to a complex number, okay, we're referring to some number that often is represented by the letter Z. We call it like, Z1, Z2, Z3, all these different complex numbers, but Z. And we say that Z is equal to some A plus BI, where we're going to refer to A as the real part of this number. This would represent some real value. And B, as a matter of fact, B is a real number, but when taken times I, all of this right here represents the imaginary part of this number. So in essence, what we're doing is we're taking a real number plus an imaginary number, and what we get is this combined number here, A plus BI, that we refer to as our complex number. And to be very clear on this, we refer to this complex number right here in A plus BI form as being in what we call standard form. So the standard form of a complex number is A plus BI form, and we're also actually going to refer to this going forward as also rectangular form. And we're going to see why here presently, because we're going to graph some complex numbers here. And so let's go ahead and start with this. We'd say that just as a point in the xy coordinate plane can be represented by some distinct x and some distinct y. That is, we could say there's only one x and one y that would get you to a specific point. We say that complex numbers of the form z equals a plus bi can also be represented by a distinct point, but we're going to refer to this point as a and b. And so what we're going to say here is that every complex number a plus bi has a point. Okay, this is our number. All right. Has a point in the complex number plane that we're going to refer to as a comma b. And the a and the b that we're using over here are just the coefficient of I and then also the real number part here. And so we could say that graphing these, essentially what's going to happen is this. We say that graphing in the complex number plane, okay, this is not the real number plane. We're going to refer to this as the complex coordinate plane. In the complex coordinate plane, we refer to the horizontal axis here as our real axis. And you notice down here that it says A, the real part of our number is going to correspond to this real axis. Likewise, the vertical axis we're going to refer to as our imaginary axis here. And you can see that even on the imaginary axis, there's this notch mark B, but the second part of this number, the imaginary part of the number, would refer to our value on the, say, what formerly was the y-axis, but now is the imaginary axis. But we say that this coordinate system, of course, is called the complex coordinate plane or the complex plane. But every complex number, basically, like we've said here, corresponds to a point in this plane. And so when we graph z equals a plus bi, basically what I want everybody to see here is this. This a plus bi would correspond to this point a comma b. And the way we would graph this is on the real axis, we would go right a units, and then on the imaginary axis, we would go upward b units, and we could say that really this is just some point AB. I mean, quite literally, we could say that this is a in distance and this is b in distance. And so we graph these complex numbers the same way you kind of graph something in the rectangular coordinate plane, except for instead of some x and y, we are plotting complex numbers, okay? When we represent a complex number as a point in this complex plane, we're plotting that complex number there. And so we could say that even though this is the point AB, and I don't have to write it again here, it's already written here, but it's literally the number a plus bi. And so what I want to do in this video is I want to look at graphing some of these here with you and then have you try some on your own. But looking at these here, we say this first a, b, c, and d, it just says, would you plot each complex number in the complex plane? And so what we're going to do is we're actually just going to form one, not xy plane, but real and imaginary plane here. And so we'd say this is our real. We don't have to label this, but I am going to write this, the real and the imaginary axes. And so with our first number here, 3 plus 4i, we could see that our a part, our real part is 3, our imaginary part is 4. So we could say that with a of 3 and b of 4, really what we want to get our brains used to seeing is that this is some point 3, 4. And so to graph this, hey, no problem. We've graphed lots of points in the past, and because it's just like the rectangular coordinate system, when we graph this, it's in standard form or rectangular form, we can just go 3 right and 4 up. And we're going to put a dot right there. And as a matter of fact, we're going to call this, we'll call this Z1. So I'm going to label this. We say Z1 here. We'll go Z2, Z3, and Z4, little subscripts to represent that these are different complex numbers. But Z1 right here is this point that goes right 3 up 4. Now when you look at B here, Z2, it looks like we have an a value of -1 and a b value of -2. This just means that we're going to go left 1 then on our real axis, since it has a real value of -1, and then down 2 on our imaginary axis, and then we'll just draw our dot in right there. So this is our point Z2, and it lies in quadrant 3. Now, with respect to Z3 and Z4, you'll notice that Z3, I'm going to rewrite this as Z3 equals negative 3 plus 0I. And the reason why is because we have no real part. There's no real, imaginary part. We have a real part. We have no imaginary part of this. And so when we lack an imaginary part, I want you to know that we could certainly write this as negative 3 plus 0I, and it's not a necessity to do so, but that would be the same thing as just negative 3 on our real axis. So to go left 3 and draw a dot, we would say, well, then Z3 lies right here. And one thing we want to mention is this. If the imaginary part of a number is 0, then it is a purely real number. And so this purely real number, I want you to notice where it lies in the complex number plane. A purely real number must lie exactly on the real axis because its imaginary part, its up-down part, was 0. Likewise, down over here, we'd say that this is a purely imaginary number. And the reason why is we could write this in standard form as Z4 equals 0 is our real part plus negative 4I. And so our point here, our ordered pair that would correspond to this AB, would just be 0 and then down 4 here. We'd say that this is the point Z4 here. And we could say that this is a purely imaginary number. And so what I want you to do is go ahead and take a second here to plot these points on your own here and see what you come up with, and make sure you label them and also identify any of these if they are purely real or purely imaginary. Cheers.